Hello everyone, and welcome to Think Like a Software Engineer, Episode 6. The most fundamental skill that a software engineer has is the ability to give instructions to the computer. The most fundamental skill needed to accomplish this is understanding exactly what your computer can and cannot do. Now, different types of computers can do different things, and different programming languages can do different things, but whatever hardware and software you're using, you need to know what they can and cannot do. This is really the thing that trips up newcomers to programming. Most people do not understand the constraints that a computer has. If you wanted your computer to bake a cake, for example, you couldn't simply rip a recipe out of a cookbook and enter the details into the computer, even if your computer had robotic arms. The instructions need to be entirely different because a computer does not understand things the way human beings do. The software engineer embraces the constraints of the computer and figures out alternative ways to get the computer to accomplish the task at hand. So let's go ahead and solve a particular problem that would be easy and intuitive for a human, and then see how we'd have to give more explicit instructions to get our computer to solve the same problem. So let's talk about solving a particular problem called the map pattern. The map pattern is quite simple. We basically take a list of items, which is in programming jargon typically referred to as an array. We're going to take an array of items. Let's talk about an array of numbers. So here we have an array of 5 numbers, 4, 6, 8, 1, and 3. The map pattern says, let's take this and create a new array from this original array, where each item in the new array corresponds to its respective item in the first array with some sort of transformation. So let's say the transformation is that we're going to multiply each of these items by 2. So the map pattern would have us create a new array that would be 8, 12, 16, 2, and 6. So as you can see, each of the items in the new array is the multiplied by 2 version of the items in the first array. If we wanted to take this same array and apply the map pattern, just this time we subtract 3 from each item. So the new array would now be 1, 3, 5, -2, and 0. So you just watched me solve the map pattern as a human being. What did I do? I just wrote up a new array, looked at each item, and in my head did the calculation of either multiply it by 2, subtract 3, and just add the new items to the new array. The instructions that we're going to give to the computer, although similar, need to be somewhat more explicit. We need to take into account the constraints that our computer has. So let's assume that we're working with a standard programming language such as Ruby, Python, JavaScript, etc. How do we get the computer to take an array and apply the map pattern to it to produce a new array? So first, let's talk about the tools that the standard programming language has at its disposal. We're going to make a list of these tools. The first tool we're going to discuss is the concept of an array. These programming languages can allow you to create an array and to work with arrays. Specifically, we can create an array. We can add something to the end of an array. And we can check what item is at each index of an array. What is an index? The index is simply the spot within the array that each item is at. So here we have an array, and you can see it contains these various fruits. However, each item inside the array has a number assigned to it that represents the spot in which this item is contained within the array. So arrays in most languages actually start at index 0. So apples is actually stored at index 0 within this array. Bananas is stored at index 1, and so on and so forth. So these are some of the tools that the computer has involving arrays. Another basic tool that programming languages can typically do are create and update variables. A variable allows us to simply, it's like a box that we can store a piece of information in it to hold for later. You'll see this in action coming up. Another tool that a programming language has is to do basic math, like addition and multiplication. And yet another tool is to create something called a loop. A loop allows us to take a bunch of lines of code and have it run repeatedly many times in a row. We could also make the loop conditional and say that the loop only runs while a certain condition is true. Okay, if you're brand new to programming, some of this may be a little difficult to understand, but hopefully you'll understand the example as I run through it. So now that we know these tools, let's actually put down here some pseudocode, which is basically writing code in English to spell out how we would tell the computer to apply the map pattern. So we're going to start out by creating a variable. Again, that's like a box that stores a piece of information for later use. I'm going to call the variable array, and I'm going to put inside of it our example. Obviously, this can be replaced with any other example array. Now, our goal here is that we're going to create a new array from this array. That is what the map pattern is. The new array is going to have the same number of items as the original array, but each item from the first array is going to be transformed in the same way and appear in this transformed way within the new array. So I'm actually going to create another variable called new array. This is where the new array is going to live. Now, while a human would simply solve the problem right here, right now, by looking at each item from the original array and multiplying each one by 2 in their head and dumping all the information here, the computer cannot do that using the standard programming language. So what we have to do instead is create an empty array. So an empty array is basically a list with nothing in it. This is a fantastic example of where human thinking and computer thinking diverge. Humans would never create an empty list. That is entirely useless. But for the sake of solving this map pattern, we have no choice but to start our computer out with an empty list in which we're going to add the transformed numbers into it in our code coming up. Next, we're going to create another variable called index that I'm going to start out as the number 0. We're going to see why we need that in a little bit, but this is going to represent the index within the original array. We are then going to start a loop. In the loop, we're going to do several things. First, we're going to find the number at the index within the array. So what does this mean? Right now, our index variable is 0. So we're going to find the number within the array variable whose index is 0. Because remember, that's one of the tools that we have at our disposal. We can check what item is at each index of the array. So since index is 0, we're going to look up within the array what value is inside index 0. In this case, that just happens to be the number 4. Next, we're going to then multiply the number by 2, and then we're going to take the result and throw it at the end of the new array. Another tool we have is to add something to the end of an array. So then add result to the end of the empty list that is contained within the new array variable. So now the new array variable is actually no longer empty. It is now going to contain the number 8. Next, we are going to increase index by 1. So one of the tools that we can do is to do basic math. So we can take the number that is stored inside the index variable, which right now is 0, and increase it by 1. Now, since all this code is contained within a loop, that means it's going to run again. So starting up at the top, we're going to find the number at the index within the array. Now, right now, index is actually 1. So we're going to find the number at index 1. That just happens to be the number 6. We're then going to multiply it by 2, so that's 12. We take the result of 12 and add it to the end of new array. So the new array variable now contains a 12 at the end of it as well. We then increase index by 1, so index is now 2. We then begin the loop again. So we find the number at index 2, that's the 8. Multiply it by 2, that's 16. Take the 16, throw it at the end of new array. Increase index by 1. So now we have an index of 3. We begin the loop again. We find the number at index 3, that's the number 1. Multiply it by 2, so that's 2. Add the 2 to the end of new array. Increase index by 1, so now index is 4. Beginning the loop again, we find the number at index 4, that's the number 3. Multiply it by 2, so that is a 6. Throw the 6 at the end of an array and increase index by 1. So now index is 5. Now here we run into a little bit of a snag, is that even though as humans we know that our work here is done, the computer is dumb. The computer needs to be explicitly told that their work is done. Otherwise, what's going to happen is that the computer is going to start the loop again and try to find the number at index 5. But if you look, there is nothing at index 5. This array ends at index 4, and then bad things will happen. Perhaps an error, depends on the programming language, but definitely unintended consequences will occur. So what we need to actually do is put a constraint on the loop. So one of the tools that we have is that we can run a loop only while a certain condition is true. So we can loop only as long as the number contained within the index variable is less than the number of items within the array variable, which makes me realize that I neglected to inform you about another tool that we have with arrays, which is that we can check the number of items within an array. So something a programming language could do is look at an array, tell you how many items there are in it. So in this case, the array has 5. So we're only going to run this loop while index is less than 5. If we had an array that had 100 items, we're going to run this loop only as long as index is less than 100. So once we break out of this loop, we can then finally produce our output of the new array variable, which is going to contain the brand new array that had the map pattern applied to it. In this case, multiplying each number from the original array by 2. If we wanted to apply the subtracting 3 map pattern, all we have to do is change this line here. Instead of saying then multiply the number by 2, we can then say then subtract the number by 3. But the rest of the structure here will apply to any map pattern. Thank you for joining me, and I'm looking forward to meeting with you again next week.